Become a smart city innovator. More than 20 years of experience, 20,000 students and 120 countries. Masters in Global Smart City Management. Enroll now.
Hello everyone, and welcome to today's session, Digital Twins Driving Smarter Urban and Infrastructure Decisions. Thank you for joining us. In this session, we will explore how digital twins are transforming the way we plan, build, and manage cities and infrastructure. From early stage planning and design to construction and operations, these technologies empower smarter decisions, predictive analysis, and data-driven optimization throughout the entire life cycle. My name is Thaisa Figueiredo. I'm Institutional Relations and Program Owner here at Ziggurat, and I'm thrilled to be your host today. And for those if you are new to Ziggurat, here's a quickly introduction. We are online education institution with over 20 years of experience in e-learning. Our programs cover architecture, engineering, and technology management, helping professionals worldwide boost their careers. And we are proud of our global community. We have more than 20,000 students from over 100 countries. So at Ziggurat, we believe in unlimited possibilities, unlimited knowledge, future success, leadership, and imagination. So, and that spirit of limitless growth starts right here with all of you. And before we dive in, let's make it a little bit interactive. Please share with us in the chat, where are you joining us from today? I'm joining you from Barcelona. So I'm sending you a hello from Barcelona. And I would love to know, where are you connecting with us? Let's keep the energy high today, okay? And today's session is deeply connected to one of our flagship programs, the Masters in Global Smart City Management. This program equips professionals to develop and manage sustainable, innovative, and inclusive urban initiatives based on the best international standards. To tell you more, please welcome my colleague, Elena, a career development and admissions constant here at Ziggurat. Elena, thank you, and it's over to you now.
Thank you, Thaisa, and welcome everyone. Today, I would like to introduce you to the Masters in Global Smart City Management. As you can see from the title, this program is about reshaping cities and transforming lives. The idea is simple but powerful. How can we design and manage cities that are not only smarter, but also more sustainable, inclusive, and truly focused on the well-being of citizens? These masters offer a one-year program fully online in English, awarding a dual degree from Ziggurat Institute of Technology and the University of Barcelona. It's structured around 60 ECTS credits, giving students both the academic rigor and the practical tool to engage with the real-world challenges. So, from the very beginning, the program invites students to think big, to imagine cities of the future where technology, human needs are balanced, and where innovation leads to a better quality of life for all. Next slide, please, Thaisa. This slide shows the roadmap of the Masters. It begins with a welcome block to set the foundations, followed by the three main blocks: strategy and citizens engagement, technology and tools, and sustainability and resilience. Finally, students complete a final master project, developing throughout the year to put theory into real practice. Three dimensions: quality of life, technology, and sustainability. Okay, next slide. Why choosing Ziggurat? Because it's a top-ranking Masters in Urban Planning, recognized for training experts in smart cities. This program stands out of its interdisciplinary approach, combining different professionals' background, and for offering an integrated vision of smart cities, covering citizenship, mobility, and environment. Most importantly, it provides hand-on learning with real case studies, preparing students for a real-world impact. And on the next slide, another strength of Ziggurat is its global network. Alumni and local hubs are spread across the world, creating opportunities for collaboration and connection everywhere. The program follows international best practices, offers personalized support, and connects students with a diverse global community. Most importantly, it opens career boost opportunities, linking graduates to international companies and real projects. And finally, next slide about the career opportunities. This master opens door to a wide range of career paths. Graduates can work in urban technology and digital solutions, in startups and enterprises, or smart city consultants. Other opportunities include urban planning, project management, and managing city services and operations like energy, transport, or waste. In short, it gives professionals to lead innovation and sustainability in the cities of tomorrow. So this master's is not just about managing cities, it's about transforming the future of how we live in them. That's all from my side. Now Thaisa will continue.
Thank you
Thank
so
you.
much. Thank you so much, Elena. And now it's my great pleasure to introduce our speaker for today, Hesham Gamal. Is an engineering strategic advisor with over 15 years of experience in digital twins, smart cities, and giga projects across the Middle East. He specializes in digital twin strategy, BIM, GIS integration, and business value delivery. And currently, he serves as digital twin and smart cities manager at Esri, Saudi Arabia, is a professional member at the Smart City Council and proudly a Ziggurat alumni. Before I pass you the floor, Hesham, a quick reminder to our audience. Feel free to send your questions and your doubts in the chat. We will address them at the end of the session, okay? In the Q&A part. Hesham, welcome. It's a pleasure to have you with us today. And the stage is all yours now. Thank you so much.
Thank you, Thaisa. Thank you, Elena. Let's go. Okay. First of all, thank you, Ziggurat, for this opportunity and hosting the session. My name is Hesham, and today we're going to move beyond the buzzword and dive into how digital twins are fundamentally changing how we plan cities, build and manage our cities and infrastructure. We will define what they truly are. We will try to make it interactive. Of course, the topic is, as you know, you already know, might know that it's kind of complex, but we will try to simplify things as much as we can. We will try to touch base on as much as we can from the components. And the most important thing from my perspective is to get a solid output from today's session. So the session will focus on the digital twin in action through global case studies and look at the future where AI brings them to life. Okay, the urban challenge, and actually Elena introduction was kind of better even than my introduction to the session. So as we already know that the cities and infrastructure systems worldwide are facing multiple challenges. The traditional planning and management approaches that we already know are reactive, and it leads us to responding to problems rather than preventing them from happening. And in this case, we're kind of gambling the future, and we're suffering from chronic traffic congestion, and I believe in most of our cities, aging infrastructure, climate resilience gaps, and the complexity of coordinating multiple systems, multiple ministries, organizations, and municipalities. And the critical question that faces us is, and faces actually every urban planner or infrastructure manager, is how do we transition from reactive crisis management to predictive, proactive decision making? Okay, so as we mentioned, SDG 11, which is the Sustainable Cities and Communities, and its related targets from the other SDGs are increasingly challenging. And how do we make our cities inclusive, safe, resilient, and sustainable with the complex pressures of today? Our traditional tools, I believe, are no longer sufficient. And in this space comes the term digital twin. It's a term that is often misused, maybe often confused with other technologies like simple 3D model. So let's cut through the hype with an authoritative definition from international standard, which is ISO/IEC 3173. It states that a digital twin is a digital representation of a target entity with data connections that enable convergence between the physical and digital states at an appropriate rate of synchronization. And in the upcoming minutes, we will break down why this definition is so critical. Because, as you know, there are multiple definitions, and maybe it's different between between a software vendor to another software vendor, between service provider and another service provider. That's why today I decided to use one authoritative definition from organization like ISO. And all the upcoming slides, when we define which is digital twin and which is not, it's all depending on the ISO definition. So the digital twin definition, the key is its keys is the components. First, we have the target entity. It could be a pump, a pipeline, a building, an airport, an entire city. Then you have the digital representation. This is the virtual model, but the magic is in the data connection. This is the bi-directional flow of data from sensors, from systems that keeps the digital model synchronized with the real world. And finally, and this is very crucial for the ISO definition and very transformative, is the control loop. This is where insights from the digital model are fed back to control and optimize the target entity. Without this dynamic connection and feedback, you have just a digital model, not a digital twin. So to make it clear, and actually these are the four pillars, main pillars for our today's session, and all the upcoming slides we will try to solidify the definition and their four pillars as the main pillars and foundation for building a digital twin system. So what is the digital twin is not just a 3D BIM or BIM model. So static 3D models, even if it has information and intelligent BIM models, it lacks the essential data connection that make digital twins dynamic and responsive. Without synchronization, it's visualization, not twinning. Digital twin is not just a simulation. So while simulations run scenarios, they are disconnected from real-world operations. Digital twins maintain continuous connection to the target assets and real-world assets. It could be physical systems, forming a true control loops. So again, it's the differentiator, the main differentiator, the control loops. And of course, it's not just an IoT dashboard. Dashboards monitor and display data, but digital twins go further. They analyze, simulate, predict, and enable action. Monitoring is just a starting point. So everything we do, every piece of technology we're studying, we use, it has to have a business value. So digital twin, it helps to deliver measurable value at every stage and the asset life cycle. And of course, the digital twin helps us to test and validate, so simulate scenarios and investigate potential failures before they occur in the real world. And this can be a huge reduction in risk. Also, remote operations. Digital twins helps to do troubleshooting for incidents, diagnose problems, and all of this from your place, from your location, remotely, minimizing downtime and site visits. Digital twins lower operating expenses and reduce risk through predictive maintenance and optimized resource allocation. And this is how the data-driven approach and the AI approach comes together to maximize the value of digital twins. And of course, digital twins build resilient and data-driven cities with clear visibility into operations and stakeholders' confidence in decision-making, which will, of course, by default, reflect in transparency. So to cut it short, I found that the easiest way to explain such a multidimensional topic is to start applying the concept on some implemented or existing case studies. So let's start with one of the most famous, popular airports around the world, which is Amsterdam Airport Schiphol. So Amsterdam Airport Schiphol is a fantastic example of an operational digital twin. In 2017, Schiphol Airport embarked on an ambitious capital improvement program involving major renovation and new construction to maximize the value of digital assets created during this process. The airport developed a comprehensive digital asset twin. So it's a huge airport. It's a huge piece of infrastructure, and the digital twin of the airport needs to be the unified platform that manages more than 80,000 assets, indoor and outdoor. You can imagine the number. On a space across 7,000 acre complex, from networks, runways, lighting systems to information booths and fire devices. And the airport, you might know that it ranks as number 11 on the list of world's busiest airports by passenger traffic. So the system needs to cover all of this. How the system actually did this? The system integrates data from multiple sources, and this is one of the main things that the digital twin should help us to do, providing a single source of information, single source of truth. So it has to bring together data and information from different data sources, including building information, modeling, BIM models, GIS data, real-time project changes and incidents. So it's maybe this is on the geometry and visually possible information. And in addition to this is the tabular information. For example, information about the project changes, real-time project changes, real-time incidents, financial information, documents, project portfolios, every detail of the building, whatever it's geometric or non-geometric element. In addition to the construction information, it was captured to have this information rich models used to analyze the design options and creating visualization. And after building the data, and we can call it like data first approach, now we start focusing on the system. So the system let us monitor and manage all the assets, bringing these systems in real time from a dashboard in real time. And if any component that make up these systems, such as like a belt, the belt or a motor is not running correctly, we can turn the equipment off, automatically produce a work order and assign maintenance crew to immediately repair it. And some of this, and at some point all of this will be automatically. And to have this predictive maintenance and automatic work orders, of course, it will need the help of AI, and we will talk more about this in the upcoming slides. Simulations. So the airport digital twin provides the opportunity to run simulations on potential operation failure throughout the entire complex, which saves us both time and money. And this actually was a quote from the head of development of the airport in Schiphol Airport. So in addition to this, you had your data foundation, your data first approach, the data foundation, and you have your other data streams like real-time information from different data sources. Now you can expand the value of this digital twins. So they also used sensor data from passengers' wireless devices to understand the movement patterns. This isn't about tracking individuals, but about understanding crowd dynamics. They can see queue times, occupancy, and the flow patterns in real time. Of course, all of this information that we can apply some data analytics on them, and this allowed the airport management to open new security lines before queues get too long, or direct passengers to crowded gates, and ultimately maintaining a safer and more secure environment for everyone. And after building this digital twin, and it's a very, very important, very crucial aspect, and a very crucial aspect of digital twin systems is the scalability. So after having, as we mentioned, the data, the dashboards, the connection with the real time, now we have the passenger tracking using the wireless devices. And the future plan, the future step for the Amsterdam Airport Schiphol is processing the large data sets in real time to enhance bird control applications and improve the runway safety. So the sky's the limit. Moving from an airport, a campus, now let's scale up from a single asset to an entire city. In Incheon, South Korea, in South Korea, has developed a city-scale digital twin. This isn't just a city model, It's a planning and operational tool. And that actually, as the size is getting bigger, the challenges is getting more. So Incheon city is the home of 3 million people. It's a major industrial center anchoring Seoul capital area, the world's fourth, supposed to be fourth largest mega region. Actually, it was the second, and now it's the fourth. Maybe that's why. And nearly 30% of population has limited mobility due to age or physical condition. So with these numbers, the city of Incheon decided to go for the digital twin as a solution, and they started to go with the data first approach. So they created using LiDAR scanning to capture around more than 150 plus points, the points cloud, the data format that is used for the data collection using scanning, whatever, like for example, drone scanning or laser scanning. So to capture, they captured more than 150 points per square meter. Per square meter, you can imagine the high precision of this virtual city. And they decided to use web scenes. It's the best solution for the data built by the city to be expanded and shared with different stakeholders or even the citizens. And by the end of 2020, the virtual city was ready to become a true digital twin. And Waterworks, which is like a water utility gov company, was the first local office to import its data into the system, deploying a water utility network model. So in addition to the data collected from the superstructure, as well the water utility network subsurface or under the surface. And here's just 6, and there's more of the use cases that the digital twin helped to support or to solve. So as a start, and it's very interesting actually that the problem was related to mosquitoes, and the digital twin supported solving that. Interesting, I think. So the mosquito diseases, it was there was like increasing the number of mosquitoes, and as a result of this, a lot of diseases was spread with the risk increased by climate change, and especially there is international travel through Incheon airport. So mosquito traps captured insects, the mosquitoes, and transmitted this data in real time. This live mosquito data was cross-referenced with other geographic data, such as weather information, such as maps, geographic information, and by visualizing the information from the mosquito traps and the location and the weather, the authorities could quickly identify the areas that has risk with high mosquito population. This allowed them to target these areas intensively with control measures rather than reacting after outbreak occurred. So before the disease like increase. The second use case is the need to speed up the emergency response time by knowing exactly where fighting resources are at any given moment. So the city started with 35 trucks were outfitted with IoT or the GPS receivers in the car, providing their precise real-time location within the digital twin. How can this be beneficial? Actually, when an emergency occurs, dispatchers can see the exact location of the nearest fire trucks on the digital twin map. And this is a direct visibility into resource location that speeds up the response time by enabling smarter, faster dispatch decision. The third use case is the need to prepare and mitigate flood damage. And this is actually one of the most common uses of digital twin simulation function. So this is a key advanced feature. The digital twin doesn't just show the current city, it runs a flood prediction monitoring system. So this is a proactive approach, proactive planning. By simulating heavy rainfall, the city can predict which areas will flood and take measures like deploying sandbags, adjusting drainage, and preparing emergency services. This moves the city from a reactive to a proactive state. The next use case is the historical lack of integrated data for critical infrastructure. And we just mentioned that the Waterworks was the first to import its data, deploying the water utility network within the digital twin. So this created a web service-based architecture for the entire city water supply management system, making it visible and accessible for different city stakeholders that needs the information about the water supply system in the city. The city plans to use a twin to manage all underground assets, sewers, power, grid, gas lines. So they like the idea of having control on water utilities. So they are planning to add more underground assets to create a comprehensive understanding that was lacking decades ago. And the next use case is focusing more on the older shopping districts, like modern digital information, making it hard to attract customers. And if you remember that 30% of the population that has limited mobility. So digital mapping of markets, the city created a detailed map of 12 historic shopping within the older area. And this data was created for the public through mobile devices. So it helped the public to get information about the store and use GPS to exact location of the store. So this is the economic dimension. And the other one is enabling the population that has limited mobility by 2D maps that show obstacles like steep slopes or stairs, or the other ways that may be more appropriate for their case. And this is how the digital twin of the ancient city helped. So in addition to these use cases, they created a 3D data, as we saw in the past slide, that the city created the 3D data as well for the 30% of the population. They can get a bit of understanding, a bit of reality of what's in the real world before they visit the actual place. So in every case, the digital twin helped by integrating discrete data into a single and visual context. And the digital twin of ancient city is used by now 500 staff members across 30 departments, and it increased 10% in efficiency among the city governmental offices. And you can imagine when they bring more people on as user for this digital twin and bring more data, like the infrastructure from the other utilities, they can have, maybe we can call a holistic digital twin that makes unify the understanding of the city in one place. And talking about a campus, a piece of infrastructure, an asset, and a city, now let's try to look at something kind of different, which is Cisco service supply chain. And this is the last case study before we jump to the last section. So the Cisco service supply chain, you can think sometimes we refer to the target entity. If you remember the ISO definition, target entity, digital representation, data connection, and control loop. So the target entity, sometimes we refer to it by physical entity, and it could be right in some context, like in the built environment context or AEC domain, but the target entity doesn't have to be physical. Target entity doesn't have to be physical. It could be a process, a real world process, like what we will see now, Cisco service supply chain. So the process of the service process, the service supply chain process within Cisco, it's starting with planning. So Cisco plans what spare parts are needed, what are the quantities, and they position this inventory across their global network of warehouses. Then the next step is the order management. So a customer reports a hardware failure and requests some repair. So he submits a request, they call it repair material authorization. And then comes the third step, which is the fulfillment and dispatch. And the correct, in this stage, the correct spare part is identified, located, and dispatched from a warehouse. And the right field engineer is assigned to perform the repair. And we're talking about a huge amount of clients, customers, and different locations across the world. And next step is the delivery, service, and execution. So after dispatching comes the service execution. And in this part, the chosen part is shipped, and the field engineer travels to the customer site to perform the repair. And there is a time, a maximum time that the engineer can serve this and to provide this service. It's not like an open time. And of course, the last step is the performance and the continuous improvement. The company analyzes the performance of its supply chain to find inefficiencies and improve future service. A supply chain delivering parts and services to millions of customer sites with a global network of more than 3,000 warehouses across more than 130 countries in response time of 2 hours. 2 hours, we're talking about millions of customers. And here comes the digital twin to help. So how digital twin can transform this service capabilities. So first of all comes the intelligent mapping. So the intelligent mapping displays the vendor's service capabilities, response areas, road networks, to calculate the optimal travel distances and shipping methods. So it defines which location that has the port and which which route you should go through to not to exceed the service level agreement of 2 hours. Then real-time or semi-near real-time awareness, so provides near real-time visibility to dispatch spare parts and technicians from the most appropriate warehouse and engineer base. And the last one is the smart matching. It matches the right talent and the location by assessing the engineer's technical skills and the warehouse processing times. So the process is the customer requests. So after the customer submits a return material authorization or a request from their location, now through the digital twin, it's automatic recognition of the customer address, calculates which warehouses can meet the contractual time, 2 hours. And the third step is actually the control loop in action, the control loop. The twin is near real time, so it searches and finds all warehouses that have the required part, calculates and using the digital route networks to see which can deliver within the promised time, and then analyzes and check the trade barriers and legal rules, because you might find a part outside of the country and there is some legal rules across border shipping. So, and it's all automatic, it's all in action. Then the system decides and acts automatically, selects the best option and dispatches the work order. And you can see that there is some implicitly AI mentioning, because we have mentioned some automatic things that needs some predictions, for example, some AI or agentic AI, as we will describe right now. So AI is function in the digital twin, but in this case, and actually I need to highlight that this is my opinion, that we have different types of AI. But we now, as you can see, that we talk about agentic AI. So we're referring to AI systems that can perceive, reason, and act in pursuit of goals, not just generate content. So if you think about, for example, the most popular form of AI, which is the generative AI, it focuses on creating, right? Creating text, images, code from prompts. But agentic AI adds agency, specialization, meaning it can plan and make decisions. And we mentioned multiple times in the past 3 case studies, some automatic decisions were made. So in my opinion, that agentic AI is critical from the other types of AI in this moment, from my perspective, that they are the critical type for digital twin systems, where the goal isn't just generating reports or visuals, but continuous monitoring of and reasoning and adjusting real-world operations. Digital twins needs the type of AI, the type of technology that supports automatic and autonomous decisions. That's why today we're going to shed a light quickly in the upcoming few minutes on the agentic AI. So as we refer to our definition and approach to define the line between which is the digital twin and what is the digital twin and what is not a digital twin, and we relied on the ISO standard for digital twin. Now we will rely on the Digital Twin Consortium AI agent capabilities. And the Digital Twin Consortium has developed a standardized framework for understanding and evaluating AI intelligence in digital twin. And it divided the capabilities into 6 categories of capabilities. The first one is perception and knowledge, and this is about understanding and interpreting sensory data from physical world. This agent ability is to sense, perceive, and maintain context awareness. The other type is cognition and reasoning, and this type of agentic AI cover planning, decision-making, logical reasoning, allowing agent to move from data to insight to action. Third type is learning and adaptation, and this is about self-improvement, how agents optimize their performance and enhance their performance and strategies based on experience. Fourth one is the action and execution. This type of agentic AI, it represents how agents perform tasks. They focus on implementing tasks, use tools, control physical or digital systems. The fifth one is interaction and communication. And this focuses on human collaboration and coordination between multiple agents. And the last one is the governance and safety. And this one is essential for responsible AI operation. This ensures ethics and trustworthiness within the system. So these 6 categories form a complete framework for analyzing or designing any AI agent within a digital twin system. Of course, we don't have the luxury of time to explain the sub capabilities of these 6 categories. There are 45 capabilities within this periodic table. And as you can see, it looks like the chemical periodic table. But the question is, from the past case studies, what could be the AI agent, whatever it's already there from what we mentioned, or it could be within this digital twin. So, for example, Schiphol Airport, it uses AI for automation. Its brain can decide in autonomous way to shut down broken escalator, dispatch a crew. This is a highly automated cognitive system. For the city of Incheon, the usage of AI for prediction can help. So its brain reasons over complex data to forecast floods, disease outbreaks, allowing the city to act before the disaster happens. So proactive, not reactive. And Cisco service supply, and they can make use of AI for optimization. Its brain performs millions of calculations to find single best way to fulfill service requests anywhere on the globe, and then automatically executes the plan. So AI is not a single feature. It's a spectrum of capabilities, and I added the periodic table, and I know that we don't have time to explain them, but just to illustrate that it's a spectrum. It's not a button that will do AI, not like a magic stick. It's a spectrum of capabilities that make that digital twin intelligent, whether it's for prediction, optimization, full automation, or whatever you want. AI is the engine inside the control loop, and you can consider it as the brain of the system. And we have talked about the digital twins using AI. We have talked about the agentic AI and how we see that it can support in even enhancing and maximizing the value of digital twins. Here's a development workflow as well by the digital twin developed by Digital Twin Consortium. It combines between the two worlds. So at the top, the digital twin stream, it begins with defining the business requirements for the use case. Then we identify the relevant digital twin capabilities and generate more detailed views of the key digital twin capabilities. So digital twin consortium, they have another periodic table, but for the digital twin capabilities, like the AI agent periodic table. So in below, you can see the AI agent stream connects directly with the identified digital twin capabilities, or to use the same requirements from the business. And we map the AI agent capabilities into the using the AI agent capabilities periodic table. So it's all business driven. And the requirements of the digital twin can be reflected into agentic AI requirements of AI requirements. Together, both the streams ensure digital twin and AI agent systems are developed coherently. So they are working together, not in isolated silos. And to conclude, that the key takeaways of today, here are 4 key action points. First, digital twin is connected dynamic system. Remember the ISO definition. It's the live bidirectional data connection that separates it from a static model. Second, value spans entire asset life cycle from planning, like ancient city, to the operation, like Schiphol Airport, to the optimization of a process like CESCO global supply chain. Third is that intelligence comes from AI agents. The future is embedding capable governed AI into your digital twins, but using frameworks like AI agent capabilities periodic table to evaluate the plan for this intelligence, focusing on the capabilities that matter most for your use case. So it's not about technology, it's about business-driven capabilities, then you go for the technology. And finally, success requires strategy and discipline. Don't jump to the technology stack. Don't try to overwhelm yourself. Start with a clear, high-value problem, define a realistic scope, assess your data and readiness, and implement in phases. Digital twin is incremental success, is iterative process, and incremental success builds the foundation for transformative impacts. And that's it for today. So as you see, digital twin represent a fundamental shift, and this area I'm very interested in. Please connect with me to continue the conversation. Have a look on the resources. I already mentioned Digital Twin Consortium AI agent periodic table, the ISO 30173 standard for digital twins, and Esri Geospatial Digital Twin paper.
Great, Hisham. Thank you so much. Let's move on to the Q&A session. We are almost out of time, so help me in these questions here. We have some questions in the chat. I will select one, okay? Because we are almost out of time. So people are really asking about the ROI, the ROI, the return of the investment. So I saw one question here from Saba. I must say that your presentation is clear and concise. Your straightforward approach made it much easier to grasp. That said, I'm curious about the financial aspect. Implementing a digital twin can be quite costly. So do you have any insights on the time frame needed to recover the initial investment? And what would be the main aspect to consider in a ROI study comparing to a traditional way to manage assets, avoiding major failure-related expense?
Okay, thank you, Sabah, for your kind words and for your question. Actually, this is a very crucial question, and I have to say that the digital twin is in the time that the BIM was there, like 15 or 20 years back. So we are in very early stage, and that when it comes to the maturity of the industry. But there's some studies, and I can actually, there's one on the top of my head, I can share it with you that focuses on the ROI and the financial aspect of implementing digital twin project, and it was implemented by a Geospatial World Consultant.
Great, Hisham. And to finish, do you want to leave a message to our audience?
Yeah, sorry, I couldn't get all your questions, but you can find me on LinkedIn. My name is Hisham Gamal Ghaffar, as you can see here. You can just maybe scan the code and find my profile. Let's keep the conversation going. As I mentioned, the digital twin industry is an early stage, and it needs every one of us to increase the maturity of the industry.
Great, Hisham. Thank you so much. I also invite you
Thank you,
all to
Thaisa.
connect with Hisham in LinkedIn, reach out to him and connect and still maintain this connection and this networking. So a big thank you to you, Hisham, for such an inspiring and insightful presentation. Thank you so much. I take a lot of notes here. It was really interesting. Thank you. And of course, to all of you for joining us today. Stay tuned for our upcoming masterclass and professional learning opportunities. Until next time, stay curious, stay connected, and take care. Thank you. Obrigada, gracias. See you soon. Bye-bye. Thank you.